Welcome to Space Chai,
where we spill the tea on all things space
covering topics from space law and policy to science and technology.
and interviewing industry experts in the field.
We hope you enjoyed this podcast. Welcome back to another episode of Space Chai. For those of you who listened to our previous episode, we went into the basics of space policy, including what space policy is, what it entails, discussed the Endeavour shuttle here at California Science Center, the history of space policy, and the space race, as well as where space policy is headed. For all of you who are joining us today for the first time, welcome. I'm your host, DC.
And I'm your co-host, Baley Wilson. All right, we got some piping tea today.
I think the first thing that we wanted to talk about was what is happening to investments in space. I think we discussed a little bit about this in our last episode of looking at where space policy is headed, but what is currently happening to space investment?
Yeah, so since 2021, investments in space have been dramatically decreasing, and I think part of that is due to the COVID-19 pandemic. But we have some numbers for y'all that roughly $50 billion in investments went to space in 2021, but that number was cut in half for 2022 with roughly $20 billion. And in 2023, it dropped again to roughly $15 billion being used to invest in space. So there's definitely clear trends of investments decreasing in the industry.
That's insane. So our funding dropped that dramatically just from 2020 all the way to this year?
Yeah, it's been dropping, but it's expected to be higher this year. For 2024, NASA has suggested that they need $27.2 billion in funding. Part of that will go to the Artemis moon mission, which is expected to launch this year. It's slated around $8.1 billion.
Yes. If I'm understanding this correctly, and just correct me if I'm wrong, I may not know. Is the Artemis mission the one that got delayed to September of next year?
Yeah, it is. Yeah, there's been a lot of delays recently. We're not 100% sure about when the launching is expected to be because we've heard different numbers throughout the years. We've heard different dates, and we've been disappointed a lot of times recently. So
yeah,
it just whatever NASA's feeling like, whatever ends up happening, but it's expected to happen in the next year probably.
Yeah, I know that the project has been scrutinized for delays and a lot of cost overruns, but let's talk about some other stuff with Project Artemis. Namely, has the lack of development for Project Artemis caused universal discouragement in investing in space, or how has that kind of been?
Yeah, honestly, I feel like it has played a part in investments going down just because it's something that's been proposed since 2017, and that's roughly 8 years ago. And I don't know, just a lot of people hearing one date, and then when we get to that date, it just gets pushed back and pushed back. There's definitely been a lot of discouragement with space investment.
That's true. And I mean, we've talked a lot about kind of federal sector, space investment. You talked about NASA's budgetary concerns. How do the trends kind of look in the private sector? Is it the same or is it different?
So in the private sector, the space-related projects secured a total of $12.5 billion in 2023, up from $9.3 billion in 2022. But it's lower than the whopping $15.3 billion in 2021. So it's definitely been having up and down shifts, but it's expected to be increasing because people are finding a lot more stability within the private sector. And I feel like part of it also has to come with distrust from the government and distrust from government programs. So yeah, we can definitely see some crazy trends in the private sector.
And where were these investments coming from?
So a lot of the investments are coming from external sources, such as venture capital firms, private equity firms, foundations, and also sovereign wealth funds. So yeah, that's where a lot of the investments in the private sector are coming from.
Yeah, that's super cool. There was this survey titled Defying Gravity, and it talked about how professionals say that funding should go to software development, system level modeling, simulation, as well as design. And there's a couple of trends that are related with shortening product development, advanced payload systems, and artificial intelligence that private sector companies are trying to use more in their private sector projects as they're relating to space. So I think that could also kind of maybe play a role in terms of why we're seeing this divergence from how space investment is being federally treated with agencies like NASA versus how like the private sector is looking at developing this. So, I mean, are we going to see any changes in like the commercial space like travel sector? And if so, I mean, what do you think those changes could look like?
I feel like we definitely are seeing some different trends within the private sector, including like commercial space travel. We're seeing a lot of increases in commercial space travel, actually, and like a lot of increased investment for it, such as like space tourism. I feel like it's becoming a very like not accepted topic, but like it's definitely coming into the media more, and it's definitely coming into like investors' minds more because it definitely is going to be a big future for the space industry because in the past, space did not seem attainable to the like average citizen. So like now that they're being able to have like the opportunity to be able to go to space as like a normal citizen, people are gonna definitely try to capitalize off of that.
Yeah, I know like Virgin Galactic has been kind of on the forefront of trying to look at like space tourism, for example. And I personally feel like a lot of that has to do with the fact that governments have like augmented funds that would have been spent on like tech development to like national security and scientific exploration. So now it's kind of given a role where private sector companies are really able to take that on and fulfill those needs because the government isn't really doing that. I mean, what else do you think has kind of been going on in that sphere?
Yeah, there's been a lot of collaboration between government agencies and private agencies, which is something that we haven't really seen in the past. We've always seen like kind of a segregated groups when it came to like spaces or space policy and like space exploration because the private sector is something that's so new. We're kind of still learning how to navigate between like the government aspect and the private aspect. A lot of people think that like government collaboration with private sector companies will benefit each other in the future. So I think it's definitely mutually beneficial.
I think I'm really curious to know, and this kind of brings us to like the next topic, which is like how have trends in climate change or what's been going on in the environment affected our timeline for space development or kind of affected the feeling that people have towards like the need to really develop in space?
I definitely think climate change and like climate related issues play a big part in it. I feel like a lot of people don't see like a necessity in space when we are dealing with our own problems here on Earth, and they see it as kind of like something that's like redundant. Why would we invest in space when we can't even handle problems? So,
So I have a
yeah.
lot of interesting data. According to the EPA, like greenhouse gas concentrations in the atmosphere will continue to increase unless the billions of tons of our annual emissions decrease substantially. And they tell us that some of the effects of the increased concentrations are projected to increase the Earth's average temperature be within the range of zero point 0.5 to 8.6 degrees Fahrenheit by 2100, with a likely increase of at least 2.7 degrees Fahrenheit for all scenarios except the one representing the most aggressive mitigation of greenhouse gas emissions. So that looks a little scary, I think, if you think about it. Like, if our increase in temperature could be anywhere from zero point 0.5 degrees all the way to almost 10 degrees Fahrenheit within, the next 100 years, that almost seems like we need to really factor in space travel and development into space as like an actual solution if we're not able to solve problems here effectively.
Yeah, and I definitely think that climate change is such like a difficult issue to like understand and a difficult issue for people to like try to fix, especially because there's so many differing opinions about what we should do to fix it. So honestly, I feel like space travel and space exploration could be like the answer if we can't figure it out. If like our relations with other people cannot come to like a complete and collective understanding about like what we should do about this. Based off the data that you mentioned earlier, what do you think this is like telling us? Like what do you think will is expected to happen?
Yeah, so the EPA has like some pretty good data on that as well. So they tell us that some of the expected consequences are going to impact the patterns and amounts of precipitation. And so that's going to have a really big impact on agriculture, for example, because it can like reduce the ice and snow cover as well as like the permafrost. It can also raise sea levels, increase the acidity in the oceans, and amplify the effects of like natural disasters or like the duration of which natural disasters last. And then on top of that, there's also threats to like human health that come along with the changes. And, it's going to really shift the ecosystem.
Yeah. Coming from like a personal standpoint, I did Future Farmers of America in high school, and like you could obviously tell from last year that something was different from the year before because we saw a lot more hogs getting like sick from the weather and a lot more hogs dying or a lot of more hogs getting pneumonia and different things like that. So there's definitely some like visual effects that you can like clear visual effects that you could like see with your own eyes and you can realize that it is an issue and that like something has to be done.
Yeah, I think it's also interesting as well because this semester I'm taking a class called PPD 361, which is like Sustainable Communities Policy and Planning with Heather Repenning. But in that class, we were talking about kind of water and we were talking about like issues within water. And I had to do like a presentation about the impacts that we've seen in groundwater, which is one of LA's main sources of water. And USC had kind of released a study on this as well back in like 2013. But our groundwater reserves have been like going down so badly and we're not able to recharge those aquifers as fast as we're depleting them, literally also in part due to the fact that even though we had an exceptionally wet year last year in 2023, our overconsumption of water and the kind of climate changes that we're seeing because of the environmental damage that human beings have been doing with the environment is also like affecting like resources that we need to live and then the quality of that and the quantity of that. So, it's been pretty insane. But, in order to kind of like understand climate change, what I think is really important, I think we also need to understand how it works. So, I mean, let's talk about that a bit, right? And also in the class that I just talked about, we read a little bit from this book called Climate Change: The Facts, and or like we got like a summary of it a bit in class, and they kind of talked about the process of climate change and how it works, which I think would be really cool for viewers to know. So they tell us that like with greenhouse gases, like the Earth's atmosphere contains these greenhouse gases, like carbon dioxide, methane, and water vapor. And these gases are natural components of the atmosphere. But human activities like the burning of fossil fuels have like significantly increased their concentrations in the atmosphere. And so what happens is like the sun's rays provide light and heat the earth. And so when this happens, some of the solar energy is absorbed by the earth's surface and some is reflected back toward space. But the problem comes when we talk about like heat retention because these greenhouse gases trap some of the heat that would otherwise escape into space. And this is a natural and vital process to an extent because it keeps our planet warm enough to support life. But with the increased concentration of these gases from human activities, right, it leads to like more heat being trapped. And so this is what causes like an overall temperature increase in the atmosphere, and that's what we refer to as global warming. And so then this rise in temperature leads to like various changes in like the Earth's climate systems. Like it can alter the weather patterns, melt ice caps, raise sea levels, and kind of the other things that we talked about with like wildlife and vegetation. So it's definitely something that is really important to understand when we talk about like environmental impacts.
Yeah, and it's definitely clear that it's been posing an issue to society. So, like, based off the trends that we're seeing in global warming and climate change, like, how's this going to affect like the timeline of us getting to space?
Yeah, so there's also like really good data that we have from the UN in their like latest annual report. And we can kind of see how like the world has been doing in what they have as like SDGs, which is their like sustainable development goals. And this I think can give us like good insight into kind of what timeline at least we should have for getting into space. We can kind of talk about some of those goals. I think one that you should touch on is maybe like the goal of zero hunger, especially considering your high school project.
Yeah, so goal number two for the UN is zero hunger. And according to the United Nations, the world has made a significant progress in reducing hunger. However, as of 2024, around 690 million people still go to bed hungry. The prevalence of the undernourishment has decreased from 14.7% in 2010 to 8.9% in 2022. And so, what this data is telling us is that the progress made reducing hunger the progress made in reducing hunger as indicated by the decline in undernourishment rates is a positive development for both Earth and for potential space development. Achieving zero hunger is crucial for fostering a healthy and productive global workforce, which could indirectly impact our timelines for space exploration and colonization. And I think by addressing hunger, societies can like nature individuals who are physically and mentally fit. potentially contributing to technological advancements and space related topics. I definitely remember just world hunger just was a huge issue. Like when I was younger, like everybody brought it up, everybody was talking about it. Like it was something that we would always hear on the news, but like never had a complete understanding of it. Like we always saw it as something that's unattainable, but just because like zero hunger is not like 100% unattainable doesn't mean that we shouldn't work towards it.
That's very true. And it is definitely interesting as well to kind of see how something like how issues on Earth, right, like can impact like our development into space, even if it's like seemingly tangential, because obviously we need to have enough people in the workforce and really just kind of like nurture our human capital and make sure that we're promoting the well-being of humans as much as we can even here on Earth, especially if we want to go and colonize other planets, because those issues that we're dealing with on Earth, it's not like they're going to be foreign issues when we go and develop elsewhere. There's still going to be elements of the ecosystems that we've created here that will go elsewhere. But I think it's also interesting to kind of talk about some of the other goals with the UN. So one of them was, kind of good health and well-being. So according to the UN, there has been progress that's made on improving global health. And so, like, life expectancy, for example, increased from 65.3 years in 1990 to 73 years in 2022. And infant and child mortality rates have also declined. And again, this is really important because the improvements in this sphere have the potential to contribute to like scientific research and innovation and advancements that are necessary for space exploration, because we're able to like conduct a lot more studies and data about what kind of nutrients human beings need and what that kind of looks like across different cultures, across different circumstances. And these advancements in like healthcare and like medical research that come out of focusing on promoting good health and well-being can benefit space travel, where like again like the health and well-being of even astronauts is really important. So yeah, there's also like some important stuff like that we can learn from like responsible production and like waste management practices that can be applied to space missions that we've been trying to really like implement to again promote like health and well-being. So I mean there's a lot of like developments that the UN has been making in the sphere with their SGDs that I think could translate really well over to climate, I mean to space exploration.
Yeah, I definitely think that like Earth just plays a bigger part in space exploration than we honestly think. Like people have always seen it as two separate entities, but in reality, I feel like because we're humans, like our environment around us just plays like such a big role. And if we're not doing the things that we can do on Earth, it's going to be harder for us to learn how to do them in space and learn how to adapt into an environment when we could have taken what we already knew from home. So
That's
like,
true.
yeah.
No, that's absolutely, I think, like a really salient point. And there's one of the other goals that really struck out to me with the UN in their SGD's report was that like goal 13, climate action. So they kind of talked about how again it's like critical to mitigate the impacts of climate change, and they have been trying to make improvements in that regard to kind of like lower emissions and work with different countries to like focus on legislation and provide outlines and guidelines that would be really helpful to the pursuit of that. But I also saw that you did a little bit of research on like goal 14, which is like life below water, and and goal 15, which is like life on land. So can you talk a little bit with us about that?
Yeah, so goal 14 and goal 15 is about preserving life below water and life on land. And preserving marine and terrestrial ecosystems are crucial for the biodiversity conservation, resource like sustainability, and maintaining like an ecological balance. And what this means is like the preservation of life below water and on land is essential not only for like terrestrial ecosystems, but it's also like beneficial for like the sustainability of Earth as like a whole. And I think that like potential space development has like also been like impacted by like preserving life on land and life on water. And I think this also like honestly ties into goal number 2 about like zero hunger, is like a big part of a lot of people's like food sources are animals. And like if we don't have the animals, or if we don't have enough animals in like just like marine life in order to like have a stable environment for people to like go without like not being hungry, then it's definitely like it just like they all tie in together. Like each goal plays like a different part of like a whole like pie. Like for like lack of better terms, like it's literally like a big piece of a pie, and each goal just plays like an important part of being a successful race, like being a successful like sheep.
Yeah, and to kind of like the point that you made about how everything is really inextricably linked, I think instead of viewing The development of sustainability on Earth is kind of a separate thing from how it affects our development in space. They really should be seen as like two sides of the same coin, right? Everything that we are able to achieve on Earth in terms of fixing these problems is going to translate to outer space because we're most likely going to have to deal with the same issues out there anyway. So there's like a really good Newsweek article actually by Dylan Taylor, who's like the chairman and CEO of Voyager Space Holdings. And he kind of discussed how being a multiplanetary species could allow humans to survive for potentially like trillions of years. And the article also like provided really good insights from Nick Bostrom, who's like the director of Oxford University's Future of Humanity Institute, which I love always getting research from them. And he's also like he's like detailed how there's like numerous existential risks that our planet has, from like a nuclear holocaust, genetically engineered mistakes, destructive nanobots, and even like the gradual loss of human fertility, that this could be like a problem that we need to address with space exploration. But then also like there's MIT research that suggests that our planet's oceans could contain enough carbon by 2100 to begin a mass extinction event.
And I feel like that like diction definitely has like a 100% negative connotation.
Right. And we had just talked about how like one of the UN's SGDs, that you discussed in depth was life on land and also life underwater. And so if we're going to have enough carbon by 2100 to where we're going to have like a mass extinction event because our oceans are, irreversibly damaged, I think that would be, really insane. But why don't we talk a little bit about kind of like some insights from the World Economic Forum, because I know they did a lot of research about this as well.
Yeah, so the World Economic Forum talks about the scenarios that could lead to humanity's downfall. An Oxford philosopher named Toby Ord states that humans have a 1 in 6 chance of going extinct this century, which is a crazy statistic. And he discusses a variety of like long-term risks that are both like existential and very difficult to mitigate. So, like, possibilities include nature-based risk, like asteroids, large-scale volcanic eruptions, and stellar explosions. And while we have the technology to like track many of these phenomena, we also don't have like the tech or like the likelihood of like developing it soon enough to prevent such large-scale eruptions or redirect like large-scale asteroids.
So basically, like we have the technology to where we'd be able to know like, oh, an asteroid's coming that could kill all of us, but we can't do anything about it.
Yeah, and I feel like honestly, like that's scary to like realize that like to realize that we're at risk of like dying. It can scare a lot of.
Yeah, no, like talk about hopelessness. It's really interesting because they kind of like follow with more insights, in that article, and they were talking about how as long as humanity is grouped together on one single planet, there will always be a greater than zero chance that we're all going to get killed at once. And they kind of they propose like a scenario, and they say like it's akin to like everyone being in the same building, and that there's always going to be a greater than zero chance of collapse or like a fire that kills everyone inside. And so essentially, our ability to make settlements on other planets is the only way we can mitigate our risk of our entire species being, destroyed, or at least we can significantly kind of curtail that possibility.
Elon Musk actually talked about this. He's the founder of SpaceX, as you guys know, and he thinks that a Martian colony would need 1 million people to be sustainable. That could scale up such a population within a country. And there are definitely like other people out there who think that we don't have like a real shot of establishing a human colony on another planet, and like considering our lack of like development in Antarctica, like in such like a harsh condition like on planet Earth, that like people just like can realize the like risks that it could be or that we could have like trying to navigate other like planets.
Yeah, I mean, while I think it is a bit of a pessimistic view, I think they do kind of make a good point, right? Which is like, okay, we still have a continent that we have yet to explore on planet Earth itself. And if we're not even able to colonize Antarctica, like, what chance do we even stand of colonizing like another planet? And while I do see the point that those Swiss scientists made, I think that, it's not as, potentially hopeless.
I don't know if you really think about it, like the temperature on Mars can get as low as -237 degrees Fahrenheit, and like if we have issues trying to colonize something where temperatures like could reach like around negative 50 degrees or more on Antarctica, like it's definitely scary to think about. Like if we're not even able to colonize a place on Earth that has like harsh or that has less harsh conditions than like our potential like places to colonize, I feel like it's definitely like something scary to think about. Like how are we going to be able to navigate it? How are we going to be able to explore? How are we going to be able to like use all the resources when we can't even do that on Earth?
I know. We might need Matt Damon to work overtime.
Yeah.
But
Yeah.
yeah. There's also like another really good article from Life Science from 2022, and they said that we as humans could become a multiplanetary species in as little as like 200 years, and that we can, if we can safely transition away from fossil fuels to like nuclear and renewable energy, then, we would have potentially like a real chance. So, what do you really think of that?
Yeah. Honestly, I feel like we definitely could become a multi-planet species. Like I definitely agree that we could there's definitely a possibility. And I feel like 200 years is definitely like it definitely gives a lot of leniency because a lot of like technological advancements can happen within 2 years. I mean, even looking back at like the computer was invented in the 20th century, and now we walk around with computers in our backpack to go to class when like people had to stay in a stationary place. So I definitely think there's like it's like a possibility that we reach those expectations within 200.
Yeah, I think it can be very difficult to kind of extrapolate just how far technological development can go within a given period of time because it's not necessarily like a linear trend we see with technology. Like something can be developed and then within 10 years that technology can completely change, right? Like, within, 50 years going from the computers that we started with to then ending up with the computers, that we have, now, or maybe a little bit more than 50 years, but still just looking at how exponential that growth is within 200 years, it may be that that could be enough time to where we'd be able to develop everything that we need to in order to travel into space.
Yeah, and I feel like there's also like you can take into account like other technological advancements that people had like previously thought would be more advanced than they are at the moment. Like even talking about like cars and how people thought like by our time we would have flying cars right now. Like um it's like crazy because there's like these expectations, but like in reality there's no way of understanding. There's no way of knowing the expectations could act like whether or not the expectations could act. So, like in terms of a timeline, I think our best indicator we have is probably NASA's 50 objectives for becoming a multiplanetary species, through which we might have an indicator of like how long this accomplishment might take. Some of the important objectives, including development in a transportation system that a crew can like routinely operate on from Earth, like Moon vicinity to Mars orbit, and like the Martian surface play a big part. And I think like the development of systems for the crew to live and operate and explore on a Martian surface to address critical questions concerning science like also plays like an immense part. And the develop like integrated human and like robotic systems within interrelationships that like enable maximum science return for like Mars's surface and orbit are like definitely like key points like recognize that like it would basically be possible, yeah, if we don't have a system where we can like kind of like fix any problems that we like potentially have on Mars. Also, NASA talks about like creating like an advanced autonomous construction and like precision landing for like the Martian surface, like manufacturing the capabilities to support a future human lunar presence and economy are definitely like key factors of it. I mean, I feel like a big part of like colonizing a different planet would be or would be like you can kind of think of it as like a pit stop. Like the moon is kind of like a pit stop to like the final destination, Mars. And like if you don't have that pit stop, then it'd definitely be harder to be able to like transport things from like Earth to Mars. Like in our we'll talk about this later, but like in order to get from like Earth to Mars, there's only like the window is only available every 2 years. So I feel like having like a launching place off of like the lunar surface would definitely be like a better like a, it definitely would be like an advancement that like is kind of necessary. Like I don't know, we need like a shorter than like a 2-year window. Um, so yeah. NASA also talks about like demonstrating the ability to use like commodities produced from planetary surfaces in space resources would reduce like the mass required to be like transported from Earth. So yeah,
Yeah, basically, what Bailey's trying to say is that we're going to be like the space Mongols. We're going to need to find a way to genuinely utilize every resource that we have to make transportation from Earth to Mars as efficient as possible, like by utilizing the moon and also developing our own resources that we can use and, developing the technology that will be sufficient enough to get us there within a reasonable amount of time and with limited as limited resources as we can have it be. So it's really interesting as well because Elon Musk, who we have talked about a bit, and he'll be like a reoccurring person, definitely. I mean, you can't really talk about space without talking about Elon Musk, but
sponsor us.
maybe. He's trying to make Mars more affordable as a way to incentivize people to populate the planet. If you kind of remember a bit earlier in this episode, we talked about how you need around like 1 million people for a colony there to be sustainable. And so in 2017, he estimated the cost of a Mars trip using traditional technology to cost around $10 billion a person, like $10 billion per person. I don't know how many people here would be able to afford that. Maybe only like the 10 richest people on the planet would. But then on top of that, he was saying that if we were able to get the cost down to around like 450K, which is around the median price of a home, then it would make space travel like more sustainable as an investment for people. And he also kind of talked about how lowering the cost would include like using reusable rockets, ability to fuel kind of mid-orbit, similar to how planes refuel in midair, and I'd also like to hypothesize producing maybe like repellent on Mars and then choosing the most inefficient, like effective propellant to get us there. One of the interesting things is that SpaceX and other like commercial enterprises are developing technologies to meet these kind of goals. So it's not really just something that they've been purely speculating, but they're also taking a lot of actionable steps to kind of make this happen. So in February of 2023, he said that SpaceX's Starship is closing the gap on becoming a fully reusable transportation system that could carry 1 million tons of cargo to Earth orbit annually, assuming that there are 3 launches every day. And then they also talk about there are other researchers who are modeling the development of an on site propellants, which they would call local Martian materials, and high propulsion systems to create fuel efficient and cost effective transportation.
So in terms of like how people could like potentially live on other planets, if we were to become a planetary species, Lynn Rothschild, who is like the senior research assistant at NASA's Ames Research Center and an expert in astrobiology, believes that humans on Mars will generate enough electricity through bacteria and grow houses of fungi, which is like pretty interesting. It's like kind of like the same system that we kind of use here on Earth. Like we reap the benefits that we have on Earth. So like, how are we going to be able to live if we can't reap the benefits on like different? And she touches on that. Like it's called living technology, is what she like has deemed the term, which like utilizes like the power of the cell, which is pretty interesting. And like she talks about how microscopic organisms will produce like silk, wool, latex, silica, and other materials which have like been vital for humans for centuries.
Yeah, especially I mean as like a senior research scientist, like to be working on all this kind of cool stuff. Yeah, Lynn Rothschild is working on really interesting things with living technology. I know that MIT had kind of started to develop what they call living robots. They're known as like xenobots, and they're super cool because they're able to use cells from living organisms to create robots that literally function and act independently on their own. And so living technology is a very new concept, but it's also something that would really make it sustainable for us to live on other planets because we wouldn't really be able to utilize like materials on Earth in how we've been traditionally using it. So yeah, that's super cool. She also mentioned how like digital information could be sent to back to biofactories on Mars using DNA sequencing, which is really cool. And they could generate and store power using living organisms. And kind of on that, I know that they did a little bit of research at Berkeley, if I'm not mistaken, about storing data in plants, which is insane. So, like storing data in DNA, storing data in plants, and all the different ways we can really compress down information and really utilize what we have here on Earth for outer space development. I think is really cool.
Yeah. The cells actually kind of reminded me of something. For those who have seen Big Hero 6, like the nanotechnology that like everybody is so obsessed with, like I feel like that's like a good example of trying to like understand what the tech like it's not something like you can control, it's kind of something that you can just foster and kind of farm. So it's like it's definitely an interesting topic. Um and Rothschild also like gave us like an example of like how one of her students incorporated silver atoms into plant DNA to make an electrical wire. So despite like the pessimism of those like the Swiss scientists that we talked about earlier, maybe it's not so many like maybe there's not so many holes in our plans to become like a multi-planetary.
That's true. And I mean, we've been talking a lot about, lowering costs with, how SpaceX and Elon Musk have been trying to do it. Living technology with Lynn Rothschild's been like working and developing on, and, our chances of dying and extinction, like 1 in 6 is insane. Again, like, what does this mean in terms of our actual timeline?
Yeah, so there's something called the Kardashev scale. There you go. In 1964, the Soviet astronomer Nikolai Kardashev proposed a measurement scheme, later modified by Carl Sagan, to estimate the technological capability of an intellectual species. It all comes down to like the energy and how much of it a species like can utilize for all of its. Yeah.
That's really interesting. Yeah. And like a bit about the Kardashev scale. I know that there's like different types of civilization. So he talks about how like a type 1 civilization, for example, can use all the energy available on the species like home planet, including all the sources of energy in the ground, and like in the atmosphere, like nuclear fission, for example, all the energy falling onto the planet from the parent star. So for Earth, this is like somewhere around 10 to the power of like 16 watts. And like a type 2 civilization consumes 10 times the amount of energy and are able to exploit the entire energy output of a single star. And a type 3 species can go even further and use most of the energy in an entire galaxy. So, like type 1, just as we covered, is using all the energy on the home planet. Type 2 is utilizing like this energy of like a local star. I know like one proposed idea of this was like the Dyson sphere. And then type 3 is looking at utilizing all the energy within a galaxy, which for us would be the Milky Way.
Yeah. And so, like, regardless, humans are well below the type 1 threshold, but our energy consumption increases with every year passing. More people are using more power per capita. Still, that power comes with like a lot of cost, namely the threat to our biosphere from the release of carbon and pollutants, and like the risks posed by the ability to use like the powerful means of like the energy storage and delivery systems for like destructive purposes, like such as like nuclear bombs, like a big idea. Like we've
That's really interesting to think about. There's also the idea of what's called like the Great Filter, and there's like a really cool video made by a YouTube channel called Kurz Gazette, which talks really in depth about this. But the danger posed by like the increased energy consumption by people might explain why scientists, for example, haven't found any evidence for advanced alien civilizations yet. Because like if Earth, for example, used all the energy, or like if it isn't special as a planet, and like life in the galaxy should have a lot more like intelligent life running around, right? Like so they talk about how, okay, well, if this is kind of the threshold that we need to be meeting for these civilizations to exist, then how come there's like no intelligent life around if Earth isn't really that special?
humans like have also like not been around for like a super long time in terms of the Milky Way, but like surely like by now somewhere like should have like reached the type 3 stage that we were talking about late or recently, and like started exploring the galaxy, like even if it's just for like a field trip, like something as basic as a field trip. Like it's crazy to think that like we're out here on Earth like struggling so hard to like be able to just explore the galaxy or like even explore within our solar system. But like there's definitely a possibility that like in some place far in like the galaxy, they could be harnessing like all powers that they can.
Yeah, and I think that's an interesting point because even though like humans haven't been around for that long of a time, like the Milky Way, astronomically speaking, like it's a boomer, right? So where are the aliens? That's the big question.
Exactly. Like there there's no reason why there shouldn't be other like species or like other like species on a.
So kind of following off of this, like the trick with the great filter is to basically avoid our own like demise and self-destruction while we scale up our energy to the point that we can reliably and sustainably exist on multiple planets at the same time, but it needs a lot of energy.
Yeah, a study published in Live Science had researchers like explore the best ways to reach a type 1 status as soon as like possible. And like the researchers following the recommendations of the United Nations Framework Convention on Climate Change found that like if we displace fossil fuels with like nuclear and like renewable energy sources, we have the potential and capability to like keep on growing in an output without putting further like strain on the biosphere, which is like really interesting to think. And like if we continue at our current rate of consumption, that we could reach a type 1 status by the year 2371. So like not terrible, but like also that's pretty far in the future. 300 years is
Yeah, that's
is
only like 347 years away.
yeah.
But also these calculations, I should add, include a lot of like assumptions about the uncertainty on the estimate is like around 100 years or so. So, it could honestly be like 500 years away, but honestly, for the timeline of humanity as a whole, that's not really that bad.
Yeah, and like you could also think about it like it says like and it's like 100 years off. So like if you really think about it, it also means that it could be happening 100 years or than projected. Like there is a possibility that it could happen within like the next 200 years, which is really like interesting to think about. Like that's only like what like 4 or 5 generations after us, like our great 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 grandchildren. Like sorry, I think that was six. That's I'm sorry, but like, but yeah, like still, like even if it is six, that's still like a relatively close time to like us in our current time. Yeah. And there's also like a really good article by the World Economic Forum that like talks about like why we need to get into space, like why it's a necessity to be a multiplanetary species. So they highlight like at the top of the article about like three key takeaways, and I'll dive more into the data. Becoming a multiplanetary species could protect the future of the human race and help humanity like reach its full potential. Human habitation across multiple planets will like create new hubs of innovation and experimentation, leading to like advancements in space and technology and commerce, significantly increasing like the government and private sector spending on like crewed space flight is like an investment in national and international security against like long tail risk. And also like talking on one of the points that it made is that like it's interesting to think that like colonization of Mars doesn't mean that like humanity 100% has. Like I feel like having a colony on Mars could like honestly be like an answer to like lowering a lot of like pollution, lowering like world hunger because there's not as many people on Earth that like need to be provided for. Like it's definitely like you could also think of it as like a way to like control the population because we when we talk about like the world population, obviously we're only talking about Earth, but like if we have a way of like diverging the world population and like separating it into like two separate places, I feel like that could like bring a lot of benefits to people and maybe even like benefits to like the other society, other planets.
Yeah, for some reason, this kind of reminds me of this like anime that I was watching called Hunter x Hunter, and they haven't gotten to what was it, the other world arc. Do you know what it's called?
Yes. Oh my god. I don't know why I'm blanking on it so hard, but like the whole concept is that basically like there's like the inner world and the outer world.
The Dark Continent.
The dark
The
continent.
Dark
Yes, the
Continent.
dark continent. And like basically it's like crazy to think that like they only in the show they only understand like the small portion of Earth that they haven't even explored the entire like there, which is like just a crazy thing to think. There's so much out there, and like you can also think of it in like terms of like us in our or in our galaxy.
Yeah, like diverging the populations to where you're trying to set up a colony there.
Yeah.
But yeah, it was really interesting to think about. And also just as like a side note, like because we go to USC and every holiday, a bunch of people kind of travel around the country and around the world. I can't imagine in a couple of centuries people being like, I'm going to summer break on Mars. And like
No, literally, like
literally
it's
my
literally like
cousins live on Mars.
yeah, that would like, but like honestly, like that's a reality that could happen. Like being like, oh yeah, like my cousin lives on Mars. This is what they did today. Like it's a crazy concept of like thinking about is that like you like the people that are close in your life. Like if we were in a different time where like uh exploration or like I don't know, I'm blinking on the word. Like if we had the capabilities to like go to Mars like on any other day, like it's just crazy to think that like you could potentially be saying like, oh yeah, like I'm gonna go visit my grandma on Mars. Like
That spaceship loud go
yeah,
crazy.
literally, literally.
But yeah, so kind of continuing off of, that whole thing. In 2021, you had like companies again like Virgin Galactic, Blue Origin, and SpaceX sending flights to like the borders of our atmosphere. And so like the response from the public either developed like the sense of like amazement in terms of like how much we as humans were able to kind of develop and at the rate we were able to develop. But then you also had people coming from a place of anger because in some ways it also symbolized the amount of inequality we have back on Earth, right? Like that being said, there are benefits of like space exploration and becoming a multiplanetary species that have largely gone unanswered in such discussions because, people have either just kind of been, again, in awe of what's been happening, or they're looking at the activities of these billionaires and thinking like, okay, like they're just using space as a playground for them at this point. But and we will kind of touch on this more in later in the podcast. But still, from this article, there's like a lot of supporters of space exploration, and they suggest that by sending like, robotic probes, for examples, to like the remote corners of the solar system and beyond, that it can teach us what we need to know about the universe at less cost and less risk than like sending people. And so that has been like a main criticism, right? Which is like, okay, we can explore space and we can do all these things that people are talking about, but why do we need to send people?
Yeah, yeah. It's just like it's crazy. It's really crazy to think about like to even like fathom that like we have to like it's like a necessity that we have these conversations at this point in time. Like it's like somebody posed the idea that like outer space could be the future. So like it's kind of like a for like society. And I feel like that's why we're like so obsessed with like wanting to be able to like harness it, like the entire solar system, entire galaxy, just the entire.
I
It's
know.
really interesting
Every time
to
we
think about.
research this podcast, even as we're like talking about it every single time, we just kind of sit back and we're like, wow, this is insane that we're having these conversations. But,
Yeah.
kind of taking things from back in outer space and coming back down to Earth. What are some of the trends that we've been seeing in kind of conflict with like displaced people, and how is conflict really affecting space development, right?
Yeah, so we can talk about like the Russian-Ukraine conflict. Russia plays like a big role in like space development and like space exploration, and like because of the Russia-Ukraine like conflict, like planetary space missions have been like immensely affected, and it's like rippling through Europe and like rippling through the entire world. That like, what is happening at like a certain place or a certain place on Earth can like have like effect for like our possibilities of getting to space.
Yeah, it's a massive wrench in our timeline.
Yeah.
But on top of that, like, I know back in the 1990s, the US and Russia kind of began like collaborating following the disbandment of the Soviet Union. And, they kind of began space development as rivals with the space race and trying to fight to get satellites and people out into space before one another. But then on top of that, like their biggest collaboration was, undoubtedly the International Space Station. But like now with the Russia and Ukraine war, they're kind of leveraging space exploration and development as a way to kind of stop the other country from doing what they think is wrong. So like for example, like typically you'll see a lot of like tariffs or economic sanctions being used against a country when they're acting quote out of line. And I've seen how that's kind of extended to space. What do you kind of think about that, and what more information do you have?
Yeah, so I'm gonna bring up a quote by James R. Miller that he said in the 1990s, which was, "In a post-Cold War world, space policy is foreign policy," and I feel like that's like it's like crazy to think about how like even through like so many conflicts we've had in the past that we're still able to like come together as like a human race and like set aside our differences, be able to like try to work towards like this collective goal. Like,
Wow, I'm just
yeah,
like that like quote like sent like shivers down my spine. He was just like space policy is foreign policy.
yeah, like it's like, but honestly, like it's 100% factual, and it's like it's hard to like kind of come to that understanding. So I'm glad that he was able to like put it in words, but like it's 100% the truth. Anything like pertaining to space has to do with other countries or other like policies that other countries have implemented or like that we've even implemented as like a collaborative group.
No, I mean, and it's a really good point to make as well because human spaceflight, kind of really became the vehicle in which diplomacy could be conducted, and to some extent the westernification of Russia as well, and their development within the space programs, showing like assimilation between Russia, the first world countries, even though Russia is deemed as was kind of like deemed as like a less superior country at that time, but it's insane that a lot of this diplomacy and international collaboration was really fostered by space development and that it was kind of the way that we did that.
Yeah, and it's like it's definitely like interesting to think about how like Russia's interest in space has like helped them like develop into like a new country. It's like it's definitely brought like new opportunities to Russia, which I feel like are like definitely a big thing to talk about because like by playing like a big role in like the development of like space exploration that like they've been able to like kind of translate that into playing like a big role in um international relations, like even things that aren't pertaining to space necessarily. Almost like immediately after like conflicts rose, immediately as in 2 days after the invasion of Ukraine, Dmitry Rogozin, which is like the head of the Roscosmos, the Russian space agency, announced that the Rosmakovs were cutting ties with NASA on the Venera D space mission, which is planned mission to Venus scheduled for 2029. And NASA was playing like an advisory role in the mission, but like since the mission was like set for 2029, Russia has been like focusing on other types of development. So like it's clear that their conflict with one country to like conflict of issues in like other countries.
I didn't even know we were going to explore Venus. What?
Yeah,
This is like news to me. I
I'm
knew that we were going to go for the moon and the Mars, but
yeah,
Venus just came out of left field.
I'm guessing that it's not a manned mission. It's probably just like a deeper dive on like what we already know about Venus. But I feel like Um, it's definitely like interesting because I think it was, I don't know if it was Venus or Mercury, but I remember like researching, and scientists had said that they found bacteria on I think it was Venus, honestly. They said that they had found bacteria on Venus, which is like really interesting to think about. It's like we've like always thought that like there's no other like type of life form, but like and like seeing that bacteria can like survive on like a planet whose climates are as harsh as Venus is, to one of the hottest or the hottest solar system.
It's a pretty
It's like
gassy planet.
yeah, like it's insane to like be able to like understand there's definitely like other life out
Yeah, in regards to kind of what I know a little bit more about like the Russia Ukraine conflict, I also know that the EU stopped collaboration with them on their mission to kind of find life on Mars. And so the launch was going to use like Russian rockets in order to get the rover to Mars. And this delay is also significant because in order to launch a spacecraft to Mars, the planets must be close enough, which again, like only happens every 2 years, as Bailey talked about. And so we can see that a lot of these endeavors that we want into space to like other planets is not just and the actions that are being pursued by one sovereign state. These are the collaborations between multiple different countries, and so these delays that are happening because of conflict is pretty insane.
yeah, and like also the actions of one country can just like cause like a rippling effect. As I said recently, like the actions of Russia have been kind of just like screw over the whole system, like the entire system of space exploration. Like one person's like decision can affect the entire project, which is like crazy. We definitely need to come together as like a collaborative like group in order to like reach these endeavors that we've been talking about.
Yeah, that's insane. So, I mean, going on top of that, I guess the main question that this all kind of comes down to is, well, why should we invest into space policy? So, Today, Bailey and I are going to spill our 5 main reasons for why we should invest. All right, let's start off with global communication and connectivity. As we talked about with these trends in conflict and with the environment and knowing about our timeline and also like our chances of extinction, one of the biggest reasons that we should invest into space policy is to help with our global communication and connectivity so that we're able to have more even data on these kinds of issues, right? So by deploying a constellation of satellites in strategic locations, global coverage can be achieved. You can also use like a transmitter, receiver, and communication be achieved through with space as the medium. And these transmitters can encode messages onto electromagnetic waves, and these waves flow through space towards the receiver, where the receiver collects the waves and demodulates them, decoding the sender's message. And this is super beneficial kind of as a communication system because it allows humans to communicate with one another for like a variety of distances. And this can assist in the efforts of alliances, treaties, as well as allowing everyday activities to become easier for Earth's population.
Yeah, and I feel like that also like ties into like the national security and defense point. National security is just like such a vital role. People can't feel secure in their development phase if they don't feel secure like where they currently. And I feel like that's like definitely important to talk about. Also, space can be used as like a means of like national security, which is like what a lot of people like fail to realize is that like in order to protect their country or like protect like like for any single country or every single country, it's like space could be used to like as like another commodity to like achieve like a means of like security. Information like collected from space informs like national decision makers about like evolving threats in the U.S. and like allied partner interests. So it's like, no, I just think that's so cool. Like it just seems like so futuristic, but like it's something that like we're actively using today. And like also space would like enable the U.S. military to like protect U.S. homelands and like advances for like national and like collective security interests with the U.S. and its allies. Also, like it allows like the U.S. to respond to like humanitarian crises more quickly and more efficiently. Like how we talked about with like our extinction events is like we have the technology to like know when it's gonna happen, but I feel like space can like kind of be like a development of like so now that we can understand how this is happening and why it's happening, maybe like come closer to like better like way to a better way to access. And so, like some examples of this are like the defense support system satellites. It's a 22,300 mile geosynchronous orbit of satellites which like protect the U.S. and its allies from detecting like missile launches to like space launches to like other nuclear detonations. And also it like integrates Earth's observation data, satellite communications, and like global positioning technology, which like enable like precise and timely information gathering, aiding in like addressing humanitarian crisis. So like yeah, just like definitely interesting to think about. I mean, like we even talk about like um a lot of our like even with like North Korea, like we don't really know a lot about it or about a lot about North Korea because there's such like a sheltered place. But using satellites, like we've been able to find out so much more about like what's actually going on in a place that's so like sheltered from the rest of society. It's crazy to think about.
But yeah, so we talked a lot about like, protection and defense with investing in space. But I also kind of wanted to talk a little bit more about like technological innovation and development, which is, I think, another reason we should invest in space. A common theme you'll kind of see through a lot of these reasons is that even if our endeavors into space don't necessarily lead to like immediate successes in terms of travel, there's a lot of benefits that we have with back home on Earth in terms of how this technology and can be used and why it's important to invest. So, kind of moving on to that, there's a lot of like direct technological advances in space exploration, right? So, like the immediate technological advancements into this include like the development of powerful rockets, advanced materials suited for the harsh conditions of space, sophisticated robotics, and innovative power systems. And these technologies contribute directly to our ability to explore and understand space more effectively.
Going off of that, like NASA's like spin-off technologies, NASA's like in particular has like had a long history of developing new technologies for space missions that have like found like widespread use in other sectors, which I think is like really important to touch on. like medical technology, for example, like innovations like the digital image processing techniques used in CAT scans and MRI technology, and like infrared ear like thermometers. I feel like that's like it's just so interesting how like something that was like initially intended for space has been able to like be used as like an everyday thing that we've been able to use to like save lives.
They've
Yeah.
created so many things too. Like they talk about like memory foam. And they originally developed that for like aircraft seats and scratch resistant lenses, but then it literally translated into so many other areas. Like, like what about environmental and agricultural applications?
Yeah, like satellite based like environmental monitoring systems, and like NASA also developed like sensors for like precision farming, which is like done wonders. Like talking about our zero hunger, like I feel like that's like definitely contributing to like us working towards
Yeah.
zero hunger.
And even like safety and transportation, like with NASA, they made a lot of improvements in like automotive safety with like better braking systems, more efficient engines, and like anti-icing systems for aircraft. Like that translates really well. And even like computing and telecommunications.
Yeah, like honestly, I feel like commuting and telecommunication like kind of goes like hand in hand with NASA, like and like with space exploration. It's like it's crazy to like think that like the demands for like space missions have driven like significant advancements in the miniaturization and like efficiency of like computing systems, like how we were talking about like earlier in the podcast. Yeah.
Yeah, I think it's definitely insane. And then they just like they have, a couple more. They talk about like material science and engineering, like they made like lightweight and durable materials. They created the GPS, which is not like a direct product of space exploration, but when they developed a lot of satellite technology, they had to make GPS possible so that you could like navigate the logistics and everything. And then they also have definitely served as like a catalyst for STEM education and innovation because they've pioneered all of these like new fields that have had to be kind of explored within space, and so the challenges and achievements of these missions have definitely inspired generations of scientists and engineers.
Yeah, it also like I'm like looking back on the movie Hidden Figures. Like I remember one of the scenes. Basically, they were talking about how like they had to invent a new math in order to like achieve their mission, and I just think it's crazy that like in order to like reach an endeavor like that, like what they were trying to do, like there was also so much advancement for like life on Earth. It's like it's just crazy to think about. It really is like how it can translate into something that's not space related at all.
Imagine what you're doing being so complicated that you have to create new math. That is like my nightmare manifested.
No, literally. Also, like, I don't know, just like also thinking about how like the invention of calculus like happened, like as like I think it happened in the 1600s, which is like crazy to think that like some of these top universities that we know like didn't even offer calculus classes for like
And they
students.
had
Like,
to create calculus in order to explain physics. Like
yeah,
they had to
like
create math to explain science.
it's just so crazy to like just like realize that like I don't know, just trying to understand stuff has like led us to inventing new stuff that makes it like easier for people to understand and like makes it as like I don't know, they just can make it as simple as a couple of numbers. It's crazy. Like
Yeah.
it really is. All right. The next topic that we're going to talk about like why we should invest in space is climate change. I mean like we've touched on it like earlier in the podcast, but like monitoring like the Earth's climate system definitely like there's satellites that are like critical tools for like monitoring Earth's climate, which like provide a comprehensive global data about like various aspects of like the climate system, including like the temperature, weather patterns, atmospheric gases, ice and sea level changes, and like even like deforestation and land use, and like touching in on those like a little bit, like um, talking about like the temperature and weather patterns, like satellites are able to um, track global and regional temperature trends and like monitor weather patterns and observe like oceanic temperatures. It's crazy.
That's insane. Yeah, and a lot of how we're able to understand more about climate change comes down to like the satellite technology that has been, produced as a result of our space exploration endeavors. And so that's been really critical. But also, another reason we need to invest into space as well for space. Like we need to study other planets, especially because like Mars and Venus have provided insights into planetary climate systems, and Venus especially because it has like runaway greenhouse effect. It serves as like a stark warning of the potential consequences of uncontrolled gas emissions. And Mars, on the other hand, can offer like the view of a planet that may have had climate capable of supporting life in the distant past. There's also like again like more technological innovation, and there's like our preparation that we need for a multiplanetary existence because we have to figure out how to live sustainably in a closed loop life support system, and that's like directly applicable to sustainable living on Earth. So yeah, there's a lot of stuff with that.
Yeah, and like we also can talk about like enhanced global collaboration and like how space missions have like often like required international collaboration. Like how we were talking about earlier, like we can't do this alone.
Yeah, and that kind of brings us to the last reason of exploring space, something that it's last but definitely not least on this list, but extinction. As Bailey kind of talked about earlier, if there's like a 1 in 6 chance that we're literally going to go extinct by the end of the century, I think we should definitely talk about that, right? And so, yeah, the Future of Humanity Institute at Oxford in 2016 estimated a 19% chance of human extinction before 2100. And NASA warns that there's a 0.1% chance of an asteroid big enough to level a city hitting Earth each year. And so, this is kind of crazy.
Yeah, and it's like it's definitely vital to invest in space because like our probabilities of getting like annihilated, we think like of like issues like science fiction or like a far away like when in reality these events are like closer than we realize. Like literally even today, like as we're filming right now, like there could be an extinction event that like could just happen. We'd all be gone. Like just the possibilities are so crazy.
I
It's like
wouldn't even be able to get a Starbucks the next
no,
day. I'd be
literally. Like,
gone.
oh my god. Like, it's just so crazy to think about. Like, it literally could literally right like as within a snap of a finger. Like that's literally so Avengers Infinity War coded, but it's real. It's real. Like, I don't know. It's just so crazy to think.
Yeah, so they like one of the biggest ways in which they talk about how we have like a danger of kind of creating these extinction level events could be with like nuclear accidents, and they're called like broken arrow incidents that have often like highlighted mistakes in handling nuclear weapons that could have led to explosions, and we avoided them by sheer luck. Part of this also has to do with like our upkeep of nuclear facilities, but it's quite frightening. Like the US alone had 32 different nuclear weapon incidents in which we straight up lost like 6 nuclear weapons, and we still haven't found them, and the Soviets have lost an upward of hundreds of nuclear weapons. And so there was like a couple of examples that I wanted to talk about, but definitely to demonstrate how just again critical this is. So like during the Cuban Missile Crisis on in 1962, there were like intruder alarms that went off at the Dulles Section Center in Minnesota, and this was on October 25th. And a sentry fired shots at the intruder, and it raised alarms all over the area. And they thought the Soviets were making a move against Air Force assets. And in a frenzy, Volk Field Air National Guard Base in Wisconsin sounded the wrong alarm, and pilots literally had to scramble to get their aircraft ready to take nuclear weapons to World War III. But thankfully, the guard was able to realize that the intruder was a bear, and they were able to de escalate the situation.
Yeah, I also want to like touch on that. Like we were talking about like how there's been so many like technological advancements and like I saw on I think it was TikTok recently that like the way that the US was able to figure out that like Cuba had been working with the Soviets is that instead of seeing baseball fields being built in Cuba, they saw an increase of soccer fields being built, which like baseball is more prevalent in Cuba than soccer is. So like they were able to tell that like they're obviously creating these soccer fields for like somebody else. Like they're literally it's not for the Cubans. So like who are they creating them for? And that's how we were able to like figure out that it was like Soviet collaboration. But it's
Damn.
it's like crazy.
That's some hot chai.
Yeah.
But yeah, they talk about like more, incidents that fall in line with this, like the Palomares incident in 1966, the Thule Air Base incident in 1968, the Goldsboro incident in 1961, where literally a B-52 broke in midair over North Carolina and they dropped 2 nuclear bombs. And none of them thankfully detonated. But one of the bombs underwent a partial arming sequence, and it was later revealed that a single safety switch was all that basically prevented a full-scale nuclear detonation.
Thank
Which
the Lord for that safety switch. Thank the Lord, swear.
And then there was the Tybee Island incident in 1958 where like a B-47 bomber collided with a fighter plane and in order to and during a training exercise and jettisoned a nuclear bomb near the island in Georgia. And to avoid a large explosion upon landing, the bomb was, not armed, thankfully, and it didn't detonate, but it was never recovered and is still somewhere in the Wassail Sound. So again, there are so many incidents where we've either lost nuclear weapons, where they straight up fell out of a plane and didn't somehow detonate, or where we've thought that, other actors or countries were kind of trying to come for our safety and we were so close to literally detonating nuclear weapons when it was like a bear. A bear.
Yeah, and even we've seen in the past how dangerous these weapons can actually be. I mean, the bombing in Japan during World War II killed millions of people. It's crazy that that could have happened on accident with no intention of it actually happening. And it's just crazy. It's crazy to think that something that's so devastating that has happened to other countries has been like literally right at our front door
Exactly.
multiple times.
And so, these incidents just kind of go to show that extinction or at least an incident that could, leave collateral damage to our planet and to the people here, it's not as far off or foreign as we seem. The data from Oxford tells us that, the recollection of these incidents tell us that. And we can't sit here and think that exploring into space is not an option or that it's redundant or that it's unnecessary when, in reality, really the only thing that could stand between us being here today and waking up tomorrow is a freaking safety switch.
Literally one safety switch. But yeah, it's just crazy. It really is. It kind of has me speechless, honestly. That I don't know, just something that's so simple as a malfunction could literally just lead to entire world seeing something like this.
I know. But with that being said, guys, thank you so much for tuning in to episode 2 of Space Chai. We covered a lot of different topics today. We talked about kind of, environmental trends in conflict, our timeline for developing in space, what that development could kind of look like in space, more reasons as to why we need to invest in space, and just talking about some really crazy stories, between then and now that have all really contributed to why, at least, there's a segment of the population that believes that this is really important.
Yeah, I feel like I would definitely just sitting here and being able to have this conversation has helped me understand how big the stress is. How it's the stress is real. We need to do something to figure this out. I feel it's really getting stimulating.
Yeah. Well, so this episode has been absolutely incredible. If you guys really enjoyed this episode, please make sure to like, share, and subscribe. Send it to somebody else that you think might be a space policy enthusiast or just really has an interest in space. And teasing our next episode, we might be talking about a certain space program that happened in a continent far, far away, and they really thought they were going to take on the US and Soviets. So stay tuned for that. And that's the tea.